Which point on the curve? At the point A. Are you getting this point? So what I am indirectly trying to say that if I let's say choose a point 3, 9 on this curve, then what will be the slope of the tangent drawn to 3, 9? It will be, when we say this derivative is 2x, please substitute x as 3, you get your answer as 6. So if I draw a tangent here, what will be the slope of the tangent? 6. That is 2 times whatever was the x coordinate there. If I had said 4, 16, I am drawing a tangent. Here I am drawing a tangent. What will be the slope of the tangent? You say 2 times the x coordinate there. What is the x coordinate at 4, 16? 4. So 2 into 4 will be your answer. If I say what is the slope of the tangent drawn at 0, 0, what will you say? 2 times 0, which is 0. Now understood how that 2x is related to x square? Is that clear? So 2x is nothing but the slope of the tangent drawn at any x, and that x could be anything. It can be 3, it can be 4, it can be 0, it can be -2. What is the slope of the tangent drawn at -2? You say 2 into -2, -4. Understood? Yes.
But by definition, shouldn't it be a secant? Even though they are really close together.
Understood. That's the beauty of calculus. It is ideally a secant line and it is tending to become a tangent. So we assume that at the limiting case, when t is almost so small, the secant will translate itself to tangent at that point. Now this answers this question of Bangalore and Mysore. If I ask you, what was the velocity of your car? Note the word which I used. Instantaneous velocity of your car at 1 p.m. You'll say, now it is simple for me. I will draw a tangent at this point and I measure the slope of that tangent, and that slope will be my velocity. Understood? Is this idea set in? Yes, sure.
So if you ask us the average speed between, for example, 12 am and 1 pm, we have to draw a secant between them.
Absolutely correct. Now if I ask you what was the average speed of a car between 11 am and let's say 2 pm, then what you would do, you will connect this 2 point by a secant line and see the change in the displacement by change in the time. That is going to give you the average velocity between 11 am and 2 pm. But if I ask you now, Sneha, what was the speed of the car at exactly 10:45 am? So you say, now it is very easy, 10:45 am, I am going to sketch a tangent. So, correct? And I am going to measure the slope of the tangent. Everybody knows to measure the slope of a tangent. If this angle is known, what is the slope of the tangent? Tan of that angle. You're very smart, yes.
So basically, the average velocity approaches the instantaneous velocity as the time period is.
That's the moral of the story. Average velocity approaches instantaneous velocity as the change in the time is almost 0.
So inclination theta.
You have to make a tangent and no theta. That's it. That's going to solve your purpose. Are you getting it? So see, we started with a very initial statement, problem statement. This was a statement which we had taken in the beginning of the last class. And now we are going to get the answer. We have got the answer for it. Right? Krishna, right? No, Krishna, you are? Andrew. Andrew, you are missing. Who is Omkar? Omkar, okay. Don't worry. Your function videos are getting prepared.
No,
You'll get the videos.
he taught me what to do.
Oh, great. Please help each other out.
My good friends.
Yes. Is this idea clear? Alright. Now if this idea is clear, I would like you all to tell me if my function is x cubed the derivative of this function with respect to x. You guys know it. But let's say somebody who doesn't know it. Please use your basic limit concept and tell me the answer of derivative of x cube.
X plus delta x.
And you guys think the geometrical meaning of it. How geometrically speaking x cube derivative is whatever you said.
So basically, I have to consider a cube. Cube and I consider a change in surface area. So basically,
Surface area of volume. So three sides.
answer dx will be delta x cube is
I'm sorry.
delta if you consider the cube, the delta x, the whole
Delta x would be the nudge in the sides of the side of the cube or edges of the cube.
3x
So you need to see how your volume is now going to change because of those nudges.
3x square.
Answer is 3x square.
Yeah.
Now, if I have to solve this problem mathematically, how would I solve? I know the very basic definition of df by dx, which is nothing but the change in the output, which is nothing but f of x plus h minus. Now I'm not writing delta x anymore. What do you want me to write delta x? Okay. Divided by change in the x when this change itself is very, very small. Correct? In many books, they would directly use this formula. The derivative of a function f of x is given by limit of f of x plus h minus f of x by h tending to 0. This should be memorized because you're not going to derive this over and over again. So this is the formula of finding the derivative of any known function f of x. So now in this case, my known function is x cube. So what will be f of x plus h? Krishna, f of x is x cube. What is f of x plus h? X plus h the whole cube. Is there anybody who thinks x cube plus h cube? Is there anybody who thinks x cube plus h? No, why I'm asking you this question is because I have got responses like that. It's simple. If your f of x is x cube, f of x plus h will be x plus h whole cube. F of banana will be banana cube. F of guava will be guava cube. So whatever you put here, that function will cube it. Think like that. Understood? So don't make a mistake. Despite telling, I have seen people writing x cube plus h. That's wrong. Don't do that. Minus f of x means x cube by h, limit h tending to 0. Okay. Again, what do you want me to use? Should I use this formula?
Yeah.
Why? And see, this is a formula which says, see, there are two ways to do it. Either you expand it like using a plus b whole cube formula, or you use the formula x to the power n minus a to the power by x minus a. That's your call.
Sir, it will actually be more instructive to do that. Otherwise,
Okay.
we have to expand it.
So let's do this way. X cube gets cancelled. Pull out the h from the numerator. So I'll get 3x square plus 3xh plus h square whole by h. Keep writing limit till you have evaluated your limit. Here also write your limit. H gets cancelled. Correct? Now when you substitute h as 0, what answer do you get? This term will become 0, this term will become 0, ultimately giving you the answer as 3x square. Correct? So now don't worry, I'll not bother you asking to find the derivative in this way. Instead I'll give you a set of known results. Correct?
Yeah, so
Of course some of them will prove.
if it's f of x, then it's root x. If f of x is equal to x, then it's root x.
No, it's 1. I'll tell you how.
Oh yeah, 1
This is understood. So guys, I have a small question for all of you.
1 minus 1, 0.
X cube graph is known to
the power is x. 1 to the power 1 minus 1.
Correct?
1 to x.
Correct?
Yeah.
If I say I am drawing a tangent at a point x equal to, let's say, 3, what is the slope of this tangent?
It will be 27.
Yeah. Answer is 27. That is 3 into x square. So anyway, the question can be asked to you. Nobody will say find the derivative of x cube. An indirect question can be, if I am drawing a slope to the curve x cube at, let's say, 3, 27, what will be the slope of the tangent? So indirectly I am asking you a question of derivatives or differentiation.
So if x to the power of 4 minus 4x.
Makes sense? Ishika, makes sense? Anika, Aramya, Dhirdhir, makes sense? Okay. Now guys, I'll ask you a very small question.
Antiderivative is integral.
Take it back.
No, it's just that simple.
Since we are not aware of trigonometrical identities as of now, I know some of you are doing it. I'm going to ask you a simple question. Geometrically, prove that the derivative of sin x is the same way of saying f of x is sin x, find df by dx. It's the same thing, okay? I've just written it in a more crude way. Prove that the derivative of sin x with respect to x is cos x.
Okay, fine. Simple.
Geometrically. Geometrically. That is the question.
Can we use one of the standard expansions?
No mathematics to be used. I mean minimal mathematics. I am a person who don't understand trigonometry very well. So explain me how is the derivative of sin x cos x. Graphically I come later. First let's use geometrically. What you learned?
Oh, I did graph.
First you learned geometry or first you learned graph? Geometry, right? Nothing. I don't know anything. I just know geometry.
How is it? Think it.
Because it's the graph of sin x.
Think. Think.
And
Geometrically.
sir, are we allowed to use a little bit of angular distribution?
Yeah.
Okay.
Whatever you want to use in geometry, you can use it. No issues. Try. I mean, I'm not expecting you to come with the answer. That is what I'm expecting you to try.
Use an angular
You're changing the angle slightly. Geometrically, yes. Advait, you got the question? Geometrically means use some geometry and prove that derivative of sin x with respect to x is cos
So
x.
use a square and show the binomial.
Just like I use a square, right? Just like I use a square to show that the derivative of x square is 2x. Use some kind of geometry and convince me. But by the way, I'm a person who is very difficult to convince. So convince me somehow that the derivative of sin x with respect to x is cos of x.
Sir, I did it mathematics.
Mathematically, I don't want to do right now because we are not aware of some trigonometric identities. Let's say compound angle formula and all, we are not aware of right now.
That is the next exercise.
and try to scrutinize it. Okay, critically think. A thinking mind is always critical. Not critical in the negative sense, in the positive sense. Why it is like that? Why it is not like that? Okay, so think critically. Consider a circle with radius 1 unit. How much? 1 unit. Consider a triangle made over here, obviously a right angle triangle, such that the hypotenuse is the radius and this angle is x. When I say x, x is in radians. Okay. So can I say by simple plain trigonometry, the perpendicular of this triangle is going to be sin x. Correct? So basically you are measuring your sin x in this direction. Correct? Now I am going to nudge my angle x by, let's say, dx. Correct? And I want to know what is the nudge in the height of the triangle. Oh, so basically my new height is going to be this, right? Right? Let me draw a parallel line. So if I nudge my in delta x angle, let's say this is my delta x, this is my delta x or dx. Can I say this angle is going to be the same angle here, right?
Yeah.
Now being a triangle of unit length, what will be this length? Its length will approximately be equal to the change in the angle.
Yes.
Okay? So this triangle, I am going to little bit zoom it. So this is your dx, and this increment is actually the increment in the side of the triangle, correct?
Yeah.
Which is this part shown by curly brackets.
Therefore, this will be the cos x.
Now guys, a simple question I want to ask you, if this is x, then which angle is x? This angle or this angle?
The angle with
The top one or this bottom one?
Bottom.
This one or this one?
Bottom.
Wait 1 second.
Is this x or this x?
Wait.
Please think
It's a top one. It's a top one.
Top one.
It's a top one.
I know some of you have given the answer, but those who haven't been able to understand which angle I am talking about, do you see this angle, these two angles? It's actually in the zoom format, I have zoomed it. Which angle is x? This angle or this angle?
Top angle.
Top angle.
You want some time to think?
The top angle will be.
Sneha says top angle is top angle. Correct? Sorry? Advait? Now, apply simple trigonometry here. If I ask you what is cos of x, what will you say?
Cos of x
Base by hypotenuse. Can I say base is d sin x? Hypotenuse is? What have I got?
dx.
Correct? Understand it deeply. Right? That is going to help you do wonders in this topic.
So if f of x is equal to sin x, the difference here,
The derivative of sin x is going to be cos x. Right? And graphically I am going to support this as well. So is this understood?
By a similar argument, we can figure out the derivative of cos x.
equal my negative of
It's negative of sin x.
Okay. Now I am just giving you some examples. You may try out proving it geometrically at home, but obviously not all of them will be able to do.
that's the change.
At least it sets in an idea within you. What do I mean by derivative of a function with respect to x? It's the change in the output by change in the input ratio. When the change in the input is very, very.
So that's the change in the angle.
Anika, clear? Shravan, yes.
Derivative of cos x.
Change in the angle.
Change in the angle is there will be a change in the this direction. So it will be a negative change there. That's why it becomes negative sin x. Now, wish I could have GeoGebra today.
Why don't we just go to that class?
Now it's too late. It's okay. If let's say we have a sin x function, correct? What did we learn about derivatives graphical meaning? It is nothing but the slope of the tangent drawn at any x on the curve. Correct? So guys, listen to this very, very carefully. At this point, if I draw a tangent, you know tangent is going to be a slope of 1. It's almost a 45-degree line. Did I tell you earlier that y equal to x and y equal to sine x, they try to mimic each other when x is very, very small?
Yes.
Right? So do you see the tangent here is 1? So basically if I plot a point 0, 1, then if I move forward, here what will happen? The tangent will become 0. That means this. So if I keep on drawing tangent at every point and start plotting the x coordinate comma the slope of the coordinate, you will start realizing that the curve obtained will be that of a okay. At every point x on sine x, draw a tangent, see the slope of it, then make a separate graph of x comma m. You will realize that the graph that you will obtain by plotting x comma m would resemble a cos x graph. Right? There is a function in GeoGebra called trace the locus. I wanted to show you that, but never mind. Next class, we'll go in that room for a few minutes. We'll figure that out and then we'll come back. Make sense? Does it make sense? Good. Now, practically speaking, we never get to do such deep analysis on some problems, right? Initially, we are fortunate enough, we have a lot of time in our hand. Then we get time to do these geometrical, graphical, mathematical analysis on derivatives. In reality, derivative of some standard functions will be dumped on you and you will be asked to use them. And unfortunately, I am going to do the same with you today.
So, but they derive them mathematically.
But yes, but few of them will attempt to derive it through our mathematical understanding of limits. Is that okay?
Sir, but then do we have to work principle?
If I ask, if the question paper says find the derivative using first principles, you will have to use first principles.
Otherwise, you need to follow techniques that you want.
Otherwise, whatever technique you feel
But
like.
it's an objective paper, right?
In school exam, I'm covered. Can I give you the list now? Alright. So the list goes like this.
Like 10 functions.
List of derivatives. Don't say differentiations. Differentiation is a process. List of derivatives. Use the right word. I'm learning differentiation, and by learning that I'm finding derivatives. So list of derivatives of some standard function. When I say standard functions, means the well-known functions. So I'll make a list like this. F of x will be your function and f dash x will be the derivative of that function. So we'll start with a simple example, a constant function. A constant function is derivative is 0. Can somebody tell me why?
Because if you take this, it doesn't change.
Two reasons. A constant function will be a parallel line, horizontal line like this. Correct? Any point you draw a tangent, its slope will be 0. And by definition, there is no change in y, irrespective of whatever change is there in x.
So you could give it the biggest one possible and then
Constant function. For example, if I ask you derivative of 5 with respect to x, what will you say? 0. Derivative of 10 with respect to x, 0. Derivative of 5 with respect to x, 0. Derivative of e with respect to x, 0. They all constants.
E.
Yeah. Next is derivative of any x to the power n type of polynomial. Let's say x to the power 1, 2, 3, minus 5, minus 10, 6. Whatever is your n, your answer will be always n x to the power n minus 1.
And so when we're taking the sum of all of these sort of n x plus x squared and so on, we'll just take the derivative of each one individually.
That is going to be covered under algebra. algebra governing the derivatives. I'll talk about it. As of now, I'm teaching you how to drive. Then I'll tell you how to see the signals. Okay? Is that okay, Karthi? You're happy? Now, just to give an example to substantiate this, what was the derivative of x square? 2x. Isn't it fitting in the formula n x to the power n minus 1? Even this one will fit in the same formula because constant is like, okay, I'll tell you later on. What is the derivative of 1? 0. You know, 1 can also be written as x to the power 0. And by using this formula, you can say 0 x to the power 0 minus 1, which is again 0. Right? So this is how we find the derivative of x to the power n. This rule is called the power rule. So in future, if I use this expression, tell me the power rule. The derivative of x to the power n will be n x to the power n minus 1. Now there are some caveats here, some warnings which I want to give you. If I ask you what is the derivative of x to the power x, please note it is not this.
Because then it will become x will minus again.
Okay? What will be the answer for this? I'll tell you in some time. In fact, after some classes. Next, if I ask you what is the derivative of, let's say, 5 to the power x, please note that it is not this again.
Constant eating to the power x. What am I saying?
It's only when it is in the form x to the power n, where x is a variable, n is a constant, then only the power rule can be used, not in these cases. So kindly do not extrapolate these formulas from your end. Are you getting it? It is strictly applicable only to this form. If I say what is the derivative of x to the power minus 2, then yes, you can use this formula. You will say minus 2 into x to the power minus 2 minus 1, which is minus 2 x to the power minus 3. Or you can say minus 2 by x cube. Right? So please keep all these rules in your mind because they are the basic functions derivative. Nobody should forget it for the rest of your life now. Given that you're going to become engineers, you can't afford to forget it. Next. Sin x function. We just now discovered sin x function derivative is cos x. Cos x derivative is minus sin x. Tan x derivative is secant square x.
Cos x minus sin x.
Yes.
It's getting weird.
Basically, it is
The functions are getting weird.
cos x minus sin x minus cos x sin x.
So it moves back by 5 by 2.
Yeah, and so every 5 by 2 that you go, so after 4 5 by 2, you get back to your original function.
See, some of your friends have already studied calculus a bit. That doesn't mean you are left behind, you are lagging in any sense. You'll still catch up. Hard work, smart work. That's it. Okay. Next. Have you heard of the function cosec x? Oh, of course, you have heard of 6 trigonometric ratios. One of them is cosec x. Cosec x derivative is minus cosec x cot x. Next, sec x is sec x tan x. Next, cot x, it's minus cosecant square x. Please note down, and you have to remember this as well. Initially, later on you will realize that you know them on your fingertips. Next.
Something stupid.
Now, I told you a little while ago that 5 to the power x derivative cannot be written as x times 5x minus 1. Now I'll give you the formula for that. Any a to the power x derivative, where a is a positive number, is given as a to the power x ln a. When I say ln means?
Natural.
Sabir, ln means? Log to the base e. Log to the base e is what? Correct. So as Bharat rightly pointed out, if you have e to the power x, its derivative